Hello everyone, my name is Deepak, studying Integrated MTech CSE from VIT University. Today I am here in front of you to discuss an operating system subject topic called FCFS Scheduling Algorithm.
First, let us see what is meant by FCFS scheduling. FCFS stands for first come, first serve. We can see this FCFS in real life in a ticket counter in a queue line system. Whoever the persons come first will take the ticket and go away, followed by the next person. In the same way, that concept is applied here for the number of processes. Example, if process P1 arrives before process P2, then P1 will be executed first. Now, let us see the code using Python in detail step by step. Step 1 is function definition. We use def function in Python to define a function. The same we are using here to define FCFS scheduling algorithm, and we are printing the title of our program, and the code is given here. Step 2 is process data. That means a list of processes is being created here, and each process has its name, arrival time, and burst time. And processes are represented from P1 to P5, and 5 to 3 are arrival times, and 2 to 1 are burst times. Example, process P1 arrives at time 5 and it needs 2 units. That means here time 5 is arrival time and 2 units is burst time. Step 3 is sorting process. We already discussed whichever the process comes first will be executed first, followed by other processes. For doing that, sorting process is required because it gives the exact answer. And the piece of code is given here. Step 4 is printing table. Here the output is printed in the form of table, and it consists of headings of columns, and that columns include arrival time, burst time, start time, finish time, waiting time, and turnaround time. Step 5 is initializing values. We are initializing current time is equals to 0, total waiting time is equals to 0, total turnaround time is equals to 0. Current time is equals to 0 means the CPU starts at time 0. Total waiting time and total turnaround time stores totals for the averages. Step 6 is main loop. Now we are entering into the main loop of the code. Here for that we are using for loop, and we are using for I in range len of processes. Here, len represents length of processes. Process name is equals to process square bracket I into square bracket 0. That means that each process is taken one by one, and it extracts process name, arrival time, and burst time. Step 7 is handling idle time. If CPU is idle, it means that if no process has been allocated to the CPU, then current time jumps to the arrival time. Step 8 is calculating. And for calculating start time, the formula is nothing but start time is equals to current time. For finish time is equals to current time plus burst time. Waiting time is equals to start time minus arrival time. Turnaround time is equals to finish time minus arrival time. Step 9 is printing results. As we already discussed, the output is printed in the form of table. Now here the table consists of rows, and the rows includes the following: process name, arrival time, burst time, start time, finish time, waiting time, and turnaround time. Step 10 is updating totals. Updating totals means the totals are updated to the respective processes. Here, total time plus is equals to waiting time. Total turnaround time plus is equals to turnaround time. Current time is equals to finish time. That means that total waiting time is updated by the waiting times, and total turnaround time is updated by turnaround time, and current time is nothing but the finish time. Step 11 and step 12 are calculating averages. We know that we can calculate averages by sum of all observations by total number of observations. The same concept is used here for calculating average waiting time and average turnaround time. For calculating average waiting time, we use the formula that is total waiting time by n. Here n represents the number of processes. And for calculating average total time, we use the formula total turnaround time by n. Here also n represents the process. And the code is given here. Step 13 is Gantt chart. This Gantt chart always started with 0 and it shows the order of execution, and it also shows the process's starting time and the completion time, and the code is given here. Step 14 is running function. Now, before all what we have discussed is the code. For running that code, we need to give a function that is FCFS scheduling. If you type this line, then the code will be executed. Now the output will be printed like this along with a Gantt chart and a table. Now let me discuss with you about this table and the Gantt chart. As I already discussed that Gantt chart always started with process 0. So if we look at the output table, process P4 arrival time is 0. So the P4 enters the Gantt chart and its burst time is 4. So P4 completion time is 4. After P4, P2 process enters the Gantt chart. It is already starting with 4 and its burst time is 6. 6 plus 4 is equals to 10. So its completion time is 10. After P2, P5 process enters the Gantt chart. Its starting time is 10 and its burst time is 1. 10 plus 1 is 11. So P5 completion time is 11. After P5, P1 enters the Gantt chart. Its starting time is 11 and its burst time is 2. 11 plus 2 is equals to 13. So its completion time is 13. And after P1, P3 process enters the Gantt chart and its start time is 13 and burst time is 3. 13 plus 3 is equals to 16. So its completion time is 16. Here I want you to tell you small thing that if you want to know whether the Gantt chart we got is correct or not, at the ending of the Gantt chart, we got 16 as the output. If we calculate all the burst times, we should get the 16. If 16 is 16, both are matching, then it is correct. If you want to calculate turnaround time and waiting time, theoretically, there is formulas. And there are, for calculating total turnaround time, the formula is CT minus AT. Here CT represents completion time, that is nothing but finish time, and AT means arrival time, and WT means waiting time. Waiting time can be calculated by turnaround time minus BT. BT means burst time. Now let us see the average times calculation. Here average times is of two types: average waiting time and average turnaround time. Average waiting time formula is total waiting time by number of processes. Here 5 processes are there, so by 5, and 6 plus 3 plus 5 plus 0 plus 7 is the total waiting times which we got here in the output table. For calculating average turnaround time, the formula is total turnaround time by 5. Here 8 plus 9 plus 8 plus 4 plus 8 is got by this output table. And there are 5 processes. So divide by 5. And the respective results are 4.2 and 7.4. Now let us see the code. Up to here it is step 1. Up to here this is step 2. This is step 3. This is step 4. This is step 5. This is step 6. This is step 7. This is step 8. This is step 9. And from here to here it is step 10. And from here to here this is step 11 and this is step 12. And from here to here this is step 13. And from here to here this is step 14. Let us see how the Python code will run in Linux terminal. For that, first I open the Linux terminal. Now I am creating the new file, that is nanofcfs.py. I had chosen the file name as FCFS and I am choosing Python, so I had created nanofcfs.py, and now I am pressing enter, and I have already written the code which I have showed you in the earlier slides. Now I am pressing Ctrl X plus Y and enter. Now I am typing python3 fcfs.py. Python3 is my package name, so I typed python3 and fcfs.py is my file name. Now I am pressing enter. Now you can see here the table is displayed which I said you earlier, and the table consists of process, arrival time, bus time, start time, finish time, waiting time and turnaround time. And you can also see here average waiting time, average turnaround time, and you can also see the Gantt chart.
I hope that you all have understood about the topic. Let us meet in the another video. Thank you.